Hello students, this is Kunal ma'am here. So you are going to learn lesson number 11, work and energy. It is from class 9th. So you have learned about motion in the previous chapters. The cause of motion and gravitation also you have learned. Another concept that helps us understand and interpret many natural phenomena is work. Closely related to the work are energy and power. So in this lesson or in this chapter we shall study these concepts deeply. Now the first point is here work. So there may be a question in your mind, that is, what is work? There is a difference in the way we use the term work in day-to-day life and the way we use it in science. To make this point clear, there are many examples, so we will consider few examples to understand the work, and with the example this information will help us to know about work. Now see here, the work is said to be done when a force acts on an object and the object is displaced in the direction of the force. So what is the meaning of this? So when we can say the work is done in the science, when a force applied on an object. For example, here example of object will be a ball. You can take a ball example, and suppose you kick a ball, then the force is applied on an object. Now the object is displaced, means here we have assumed the object ball. So ball is get displaced, means after kicking a ball, the ball change its place, means the ball get moved from one place to another place. In which direction? In the direction of a force. So in which direction the force is applied, in which direction the ball is get kicked, in the same direction ball get moved. So here you can understand the object, a ball, that is get displaced. But when it is get displaced, it is get displaced after applying the force. So when a force acts on an object and the object is displaced in the direction of the force, then we can say the work is done. The work done on an object is the product of the force applied and the displacement. So here is the formula: work done is equal to force into displacement. Work done can be shown here with the capital letter W. Force can be shown with the capital letter F, and the displacement is shown with the small letter S. So work done means W is equal to force into displacement means F into S. Now this is the formula where there are the mathematical expressions in our book where you have to find out the work done. So if you are going to find out the work done, you must know how much force is applied on an object and how much distance the object is get displaced. So that will be the displacement. Now the unit of the work done is joule or Newton meter, means here the joule can be represented by the capital letter J. So when we go in the shop, when we take some sugar, so there is a unit for the sugar, that is kilogram, means we ask to the shopkeeper 1 kilogram sugar, 2 kilogram sugar, or milk unit is liter. So here the work done, like sugar and the milk, the work done also has unit, and that unit is joule. Otherwise we can use the unit Newton meter. Here N means, capital N means Newton, which is the unit of force, and the small m is the meter, which is the unit of displacement. So here Newton meter or joule can be used. If there is a force 1 Newton and displacement 1 meter, then definitely work done is 1 Newton meter. Otherwise you can say 1 joule. Now what is meant by 1 joule? Now see here, 1 joule is the amount of work done. 1 joule means it is the unit of work done. So 1 joule means the amount of work done when force of 1 Newton displaces on object by 1 meter. At that time the work done will be 1. Now here another example is given. If a force of 5 Newton acts on an object is displaced through 2 meter in the direction of the force, then work done is how much the work done? We know the formula. Work done is equal to W into S. Sorry, W is equal to force into displacement, F into S. So here in this example, the force is 5 Newton and the displacement is 2 meter. So the 5 Newton into 2 meter is equal to 10 Newton meter or 10 joule. So this is a simple example by where we can calculate the work done. And here I would like to say, in the science, the work can be done when the force is applied and the object is get displaced. So these two situations are most important, and if any condition or any example if satisfy these two situations, then we can say work is done. Otherwise, if any one of these two condition any one of these two situation is not get satisfied, then we cannot say work done. For example, I can say one example. We can say one example of one student, that is suppose Nitu is doing a lot of work. Suppose exams are very near and Nitu is studying very hard. She reads books, she writes notes, she saw the question papers, she collect the notes, she wrote every time in the notebook. So in her view, or we can say that Nitu is doing hard work, or Nitu has done lot of work. But here in the science, the work done is different. That Nitu's work we can consider in our day-to-day life. But in day-to-day life, work can be used in a different meaning or with a different mean, and in the science, the work can be used with another meaning. So in science, work can be done when the force is applied and the object is get displaced. For example, if you are pushing a car but car is not moved, so in this case work done is not done. So there is no work because the force is applied on car but the car has not displaced. So we cannot say work done. But when you apply force on the car and when the car get displaced, when the car get changes place, that time we can say work done. So here for the work done, two situations are most important and that has to be fulfilled. First situation is a force should act on an object, and another situation is object must be displaced. Then only we can say work done. So here the work done by a force may be positive or negative. Yes, work done can be positive or negative. But when we can say the work done is positive, see, very simple. Work done is positive, we say, when the force and displacement are in the same direction. And work done can be negative, but when the force and displacement are in opposite direction. So here is most important. When the force and displacement in opposite direction, work done is negative. And when force and displacement in same direction, work done is positive. Now here the work done by a force is 0 if there is no displacement. And the work done by a force is 0 if the force is perpendicular to the displacement. Example is given here. When we lift an object, the object moves upward in the direction of force. Here the work done is positive. But there is a force of gravity acting downwards on object. The work done by the force of gravity is negative. Here for this example, you can consider when you come in a school in the morning, you lift up the bag first. And when you lift up the bag, at that time, the bag is object. And when you lift up the bag moves upward in the direction of the force. How you are applying the force? You are pulling a bag. So the bag and your force is in same direction. So at that time, the work done is positive. But when you lift up the bag at the time from the ground, the gravitational force acting on a bag, at that time the force, when the gravity apply the force on the bag, at that time the work done by the force of gravity is negative. Another example is given here. A porter lifts a luggage of 15 kg from ground and puts it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. Now here we can say the porter. Porter means the person who lift up the bag on the stand on railway stations. The persons are there who carry our luggage. So those are called as porters. So that porter, even the porter lift up luggage of 15 kg. Now see here, 15 kg, this is the mass of the luggage, and from the ground that porter put that luggage on his head. So what is the distance from the ground? That distance is given here 1.5 meter. So this 1.5 meter, this is the distance, so it is called as displacement. And here the calculate work done. Here the work done is asked. Now see here, when we can say then given data, mass of luggage 15 kg, displacement 1.5 meter. Now acceleration due to gravity. We should know this. Acceleration due to gravity is 10 meter per second square. Now we will put all this value in the work done formula. Now work done is equal to W is equal to F into S. Now instead of F, here M into G is written. Now this formula is nothing, force is nothing but mass into acceleration due to gravity. So here in this example, F is equal to W is equal to F into S, force into displacement. Now instead of F, mg is written. Mg means, m means mass, small g means acceleration due to gravity, into distance, into displacement, that is small s. Now what is the mass? Mass is 15 kg, and what is the acceleration due to gravity? That is 10. And what is the displacement? That is 1.5. So when there is a multiplication of 15 into 10 into 1.5, your answer will be 225 kg meter per second square. Otherwise we can write the unit of work done, that is 225 Newton meter or joule. So like these examples are there where you have to do practice. Next point is energy and kinetic energy. Now see here, we will learn what is energy first, and then we will learn about the kinetic energy. Now energy, the energy of an object. Energy of an object is its capacity for doing work. The unit of energy is same as that of work, that is joule. 1 joule is the energy required to do 1 joule of work, and 1000 joule is equal to 1 kilojoule. There are a different form of energy. They are heat energy, light energy, electrical energy, chemical energy, mechanical energy, potential energy plus kinetic energy. Mechanical energy means nothing but it is the sum of potential energy and kinetic energy, etc. So here the energy of an object means what? So what is energy? It is the capacity of doing work. So how much capacity of that object is having for doing the work, that is nothing but its energy. And now see here, the unit of energy and unit of work is same, that is joule. So work done unit, energy unit is same, joule. Now here 1 joule means 1 joule is the energy required to do 1 joule of work. Means if we want to do 1 joule of work, then how much energy is required? 1 joule. And here 1000 joule means 1 kilojoule. This relation is given, and there are different forms of energy, where here it is written heat energy, light, electrical, chemical, mechanical. These are the examples, or these are the forms of energy. The next point is kinetic energy. So the kinetic energy of an object is the energy possessed by object due to its motion. Now what is the kinetic energy? The kinetic energy of object means what? The energy possessed by object due to its motion. So when the object is in motion, At that time the object has some energy when the object is in motion. So that energy is called as kinetic energy. All moving object possesses kinetic energy. Example is given: a falling coconut, a speeding car, a flying aircraft, flowing water, blowing wind, a running athlete, etc. All these are in motion. Now see, flying, speeding, flowing, blowing, falling, running means all here are in motion. So all these objects which are in motion, they possesses kinetic energy. And the kinetic energy of an object depends upon its speed, and the object moving faster has more kinetic energy than the object moving slower. Now here you have to notice one thing, that the kinetic energy depends upon the speed of the object. If object is moving fast, then kinetic energy is more. If the object moving slow, the kinetic energy is less. Means depending upon the speed. If the speed is more, kinetic energy is more. Speed is less, kinetic energy is less. Now, if we see the example, a person walking and another person running. The person who is walking has the kinetic energy less, but the person who is running has the kinetic energy more, because it is depend upon the speed.